I was going to eat all these Oreo cookies before we went back on, so that I had Oreo cookie stuff in my. Yeah, okay. It was not good.
No.
Error handling. Because I never make an error, so this one's all yours, babe. Because I don't make mistakes.
Well.
Clearly, if you watched any of this. Oh, that's good. So yeah, if you've been watching any of this, I constantly make mistakes, and I constantly, when I'm using commandlets, I'm going to make mistakes, and it's really great to get a helpful or useful error message, and it's also really great to trap or grab hold of an error message that doesn't make any sense and give me one that does make more sense to me. And what we wanted to do is do some basic error handling. Now, this can go very deep with the error handling, and what I've done is set up some simple examples of doing some basic error handling to get you started. And so let's take a look at this and see what you think. First of all, here's what we're going to do is we're going to show you how PowerShell treats things when errors happen. And this is actually what I think this is really cool. So this is going to be a fun little demo. And then we're going to show you how to start to trap when errors happen, and then how to deal with them, and something called a try, catch, finally block. And I've got a couple of examples. I have, obviously, since I have something that says a better example, you know I'm going to start with a lousy one, apparently. And then I'll have a better one, and we'll see what goes from there. And if, oh, please join it, because I'm going to screw this up. It's all about errors. That's all yeah. So
yeah,
here's
awesome.
the deal. $sign error action preference. This is one of the interesting things. This kind of freaks people out in PowerShell at first, that when they run something, it just does it.
Yeah.
And to me, I'm just, that's what I want. Don't ask me, are you sure? Yeah, I was sure when I typed it in. Just do it. And PowerShell does that. But that's actually controlled, though. The error action preference of getting errors and how errors get handled as it goes through and it does things is something that gets controlled. And we have this error action preference variable. What is this error action preference variable thingy?
Yeah, so basically the issue is when something goes wrong, what is the right thing to do for the user? And the real answer is, who the heck knows, right? Could be this, could be that, could be that. So what we do is we have a default answer, and then we allow the user to decide to do something differently. Well, let me give you an example. So whenever as a developer, you write code, there's always this issue of like the compiler. Should the compiler generate an error on the first error it sees and then stop? And some of them used to work that way. And so you're like, oh, okay, great, I got an error. So I go fix that error. And then you compile again. It's like, next line, here's the error. It's like, okay, well, fine, fix that. Next line. And it's like, hey, you know what? Why don't you give them all to me, and then I'll fix them all at once. And so sometimes you want it that way. Sometimes it's like, hey, I'm going to go do something to a very large set of systems, but if something goes wrong, I got to stop, and then roll it on back, right? Because it's all got to be perfect. And other times it's like, what do I know? I think everything's going to be fine. I'm not sure what to do. Just something goes wrong, come back and tell me, and then we'll discuss it. And so that's what we do, is we allow you to choose what behavior you want to have. In fact, it's a little more, the story's a little bit more complicated than that. I wish I had a whiteboard here. I could describe it. But
I'm going to use my hand, and you can just draw it there.
Well, you know, I've described this in PowerShell. It looks like a command line, right? A pipe to B, pipe to C. It looks like a traditional pipeline. But that's not at all the case. It's actually masking some amazingly powerful technology. And what happens is it's an object flow engine where A, B, C are these compute units that then get hooked up in this directed graph. Notice I didn't say acyclic graph, directed graph. And we pass control to one, and it runs. We output an object. We then give that to the PowerShell runtime engine, who looks at the data contract required by the next guy. And then the data engine does all this manipulation. Hey, can I just accept it as is? Do I have to parse it and match the properties? Do I have to do any coercion or casting or parsing required to give it to it? And then it hands it to it, and then it runs.
Which is the magic about making the pipeline work.
That is the magic.
We got into it from an administrative level, but that's definitely deeper. But that is that magic that's making that pipeline work.
Exactly. Now the original design was that the pipeline was just one of n streams of objects. So you have this object, and you have n of these streams. You got the error stream, the output stream, the error stream, the verbose stream, the warning stream, etc. And the idea was that each one of these streams could have their own pipelines. Now that was the original design. Turns out we didn't implement it that way, but I still don't know who did that. Anyway.
Call Bruce Payette.
No. Anyway, but what we do is we do treat it largely like that, but then the actions, the point is that ultimately what you'd like to be able to do is to say on the error stream, I can just run an entire another pipeline against the error actions. Now we don't implement that. What we did was we have a set of enumerated actions, and it's a little bit simpler to understand.
As a matter of fact, let's take a look at some of those. So first of all, guys, this is the first demonstration I have in here. And I'm going to run these.
We're in Mod 7.
Yeah, Module 7, and these are the scripts for Module 7. And so first of all, we have the $error action preference variable, which shows you what the default is. And this is what PowerShell is going to do when it runs into an error. The error is going to get displayed, and he's going to continue on. So let's take a look at what that looks like. I've got a simple get WMI 132.
A bunch of people will never remember this, the $error action preference. So the way I remember this, because I don't remember this, is you do a $variable. Oh, sorry, do a dir space variable colon.
Oh, okay, variable colon.
Star pref star.
Star pref
I know
star.
Pref.
Oh, pref.
And you see we have a set of preferences, and one of them is the error action preference. So that's how you're going to remember it. I know there's some variable somewhere, it had something to do with errors or something to do with preferences. Use wildcards and you'll be able to find it.
And you'll be able to find it. That's awesome. Now, guys, I want you to notice that we're not going to change the system default right now. Instead, we're going to do it with the commandlets. Take a look at this get WMI Win32 computer name. I want you to notice I'm not doing anything special, but I've got DC, not online, and client. So you can pretty much guess that there's going to be a failure. Notice what PowerShell does when I run this. I'm going to clear the screen down here.
And by the way, for you at home, you'll want to change DC and client to be like local host.
Yeah, exactly. Oh, good, great. Yeah, great. That was a good point. So let me go ahead and run it because it's all going to fail if you do it. So let me run it. You see the first one gets executed. So that was DC. We're trying to reach not online. We didn't get it, but look. I want you to notice we got the first one. We get an error message saying, hey, that server isn't available. And then it went and it did the next one. In other words, PowerShell's default is to continue. So here's the error, but I'm going to keep trying and I'm going to keep going. Now, I want you to see what some of the other options are besides continue. Sometimes when you're running this, well, I know there are some computers out there that aren't going to be available. And I don't want my screen bleeding. I don't want to see it on the screen. I just want it to run. Well, take a look. We've got get WMI object, Win32 computer name, same problem. But now I'm going to use, and I've used the abbreviated versions of this. So let me show you what the full versions are on the slide here first. We've got error action, which can be EA, and we've got error variable. Error action means we can change with the action that PowerShell is going to do, and we can store the errors in error variable. Now, if you're thinking about this, well, if I store the errors in error variable, and I wanted to make an error log, I could probably just outfile that variable, but we'll get there. So you can see that we're gonna, so take a look. I've got error action, silently continue, and EV, error variable, my error. So I'm gonna run this guy, and let me clear the screen so you can see what's gonna happen here. Now, it's still pausing because it's trying that computer that's not online, but look, this time, I just got the results displayed. I didn't see any error messages, but here's the best part. If I want the error messages, $my error has the error message in it. Also, and think about this, because we're going to do this in our script in a second. I want that error in a log file. Well, pipe it out to file, whatever you want to call it, error log or whatever. So you can then quickly dump the error out to a file. This is kind of cool. I like this because it continues. Now, this is not something, oh, by the way, I have to tell you that this is a Don Jones thing. He was trying to get this to break because he was doing not online and he couldn't get any errors. It kept returning results. And he was at a client, he's going DC, not online, client, and it kept coming back. And it kept giving him an answer for not online. And he's like, what's going on? And one of the guys says, we have a computer called not online.
Which apparently has no security. Because it lets Don Jones query it.
Yeah, because they're letting Don Jones query it. So let me show you another way, though. And Jeffrey mentioned this. Sometimes, though, when an error
That's a way to
occurs,
set low expectations at work.
I know. Ping not online. Well, wait a minute. Why are we calling it not online? If it's online, I don't get it. It's so Jeffrey mentioned this. Another thing that we can do is maybe when an error does occur, we need to go stop, because we're going to have to do a rollback or something like that. So we can do an error action of stop. And as you can imagine, I'm going to run this. Let me clear the screen down here. Yeah, let me run it up here. It'll go through, and what you're going to see is, as soon as he errors out, notice he didn't do the third computer. He stopped right away on this guy. Just stop. And now we could go on and do something else. The last one that you can do for error action is inquire. And this can be useful when you're testing something and it's not working and you're trying to figure out what's going on. Let me show you. I'm going to run this one, inquire. I usually use this when I'm trying to debug what's going on with my commandlet or something like that. Comes up and says, hey, look, I've got this error. What do you want me to do? Do you want me to continue, not continue? Do you want me to suspend? Suspend is kind of cool, right?
I love suspend.
Because if I suspend, see the special prompt? The command's still there, but in anything that I may have in variables and stuff, I can start to look at it, right?
Yes.
I can start to inspect what's going on. This is actually kind of cool. Except I forgot how to exit the suspend. Is it just exit?
Think, type, get, my friend. Think, type, get.
Think, type, get. Yes, it is. Think, type, get. So, do I want to continue? Sure, I can continue, and it'll do the last one. So, inquire can be really useful if you're having an issue, not sure what's going on, and you want to kind of debug what's going on. Now, I'm going to start to use some of these so that we can start to do some error handling. And we're going to start off with...
Wait a second, you didn't show the cool stuff.
What? I didn't show cool stuff? I thought that was cool.
Well, that's cool, but you didn't show the cool stuff.
Oh, well, then show us the cool stuff.
Okay, so let me show you this one. So it turns out that there's, on Windows, there are no process IDs that end in 3. It's actually, I think, any odd number process IDs, right? So if you do GPS,
Seriously?
pipe 2, yeah, pipe 2, select ID. Notice they're all even numbers.
Okay, and the reason for that is I've never actually noticed this.
I don't know, ask Arsenovich. some good reason for it. I don't know. Anyway, so here's the deal. So you say stop, process, but so ID 13, 23, 33. Okay, and voila, you're going to get 3 errors.
Right.
Okay, so that's the point. Is that that's a safe thing to go experiment with. Okay, this error actions, right? So you saw the error variables, right? Or sorry, the error action, right? All that good stuff. But now I want to take a second here on this error variable.
Okay.
And I'm going to use E, right? Because it's like T, but it's
like
E.
T, but it's E, because it means error, right?
So now what I have is E, okay, and I have all the errors. So that's $E of 0. Okay. Now the point of this is the first one, the second one. The point of this is it's very, very rich. Now there's a trick to this, and it's a general PowerShell technique, right? So what I'm going to say is, okay, well, I bet you there's more to it than that, right? So I say pipe 2, get member, and oh, there's a ton of stuff. Look at all this great stuff. And I say, oh, well, I'd like to see that. And so what I'm going to do is I'm going to say $E is 0, and just do the first one, format list star, and it gives me the same thing.
Yeah.
Okay, so what's happening is that the error object is treated specially by the host. Okay, details don't matter. It's treated specially by the host. In order to see all the rest of the parameters or the properties, you have to say minus force. Okay, so this, by the way, is a general PowerShell thing, and general PowerShell will do something, and if you say no, I really wanted to do this, you just say -force and we'll do it. So, if you try and kill LSASS, why don't you try that?
Serious?
It's your machine. Anyway, no, well, I'll try it. I'll try it. Yeah, because I bet you it'll work. So.
Oh, I like this. I bet you it'll work. Let's see.
Yes. Get process pipe to LSASS. Or so get process LSASS pipe to stop process. Now, if this does not work, Jason's taken over while I spend a bunch of time trying to
restarting your machine.
Okay, so and I wouldn't do this until. By the way, don't do this in PowerShell version 2. Yeah, if you get version 2, don't do that. Okay. No, I think it'll work in 2. You should try it. So what happens is, look
great.
here.
Yeah.
Okay, and so what we did was, by the way, because did not used to do this at some point, and I used to make these mistakes. So I said, hey, you know what? We should do this. So what's happening here is it'll come in and it'll say, oh, are you trying to process? Are you trying to terminate a process that you didn't start?
Oh, okay.
And if so, it says, hey, that doesn't sound right.
Doesn't sound good.
Warn. And by the way, let's make sure I get this right.
No.
No.
Is it no? No.
Now, if I wanted to, and I'm really here, what I'm going to do is I'm going to put a pound sign in front just in case. So I
smart man, yeah.
So that no matter what. And what you do is you said, no, I really want to have that do it. You just say -force. And then we'll do that. We won't tell you anything. We'll just go whack that thing. Okay? Okay, so now back here, you say, hey, I want to see these things. I really want to see it. So show it to me -force. Force. And you see,
oh, there they are.
we have all the details, okay? And there's some really cool stuff here, including target object. So target object, 13. So wait a second. So you mean I could have said like $e.target object?
Would it be E.0? Oh, so you can get it for all of them? Or you can do the individual
and
elements.
So this is the point. So now imagine, so the point is I'm going to do something on, I'm going to perform an operation on 1,000 things, 10,000 things. 13 of them fail. Oh, which 13? Well, good luck, my friend. No. You capture it as an error variable. Right. You have the target object, and those are the 13. And you say, what? Now I do a remediation action. You say $for each $. Well, what's short for E? I guess I'm kind of dumb here.
E?
I guess I'll go back to T for each T and $E. This is not best practice, by the way. And then you do something with it, right? So then you do a remediation action. Wait. Oh, sorry. E dot target object. Target object.
And then you can
do some action. Restart.
Now that's interesting because I bet you here in a moment you're going to help fix my code to be even better like that because I did something else that was
But before we do that, you didn't tell them. Are you going to tell them about the views?
The views.
The views.
The views.
Category view.
Category view.
You know about category view?
I don't think so. What are you talking about?
Okay, so again, there's some error. There's something like an error view or an error. I don't know. Anyway, so how do you find out? Dir variable. There's something about errors. So let's just look. And so, by the way, there's maximum error count. Like, don't screw that up or. Okay. No. So there's error view, and it's normal.
View. Okay.
Oh yeah. Well, that's odd, right? So
that's
odd. Let's take a look. Let's say, and by the way, here's another cool trick. Let's assign error view. I don't know if it'll work on this one. Equals. Oh, that's not good. Anyway, so you got to know category view. Okay. So you just got to know this one, and there's two views: normal view and category view. Okay. So before I set that, let's make some errors. So error number 1, stop process ID 13. Don't do that. 13 and some nonsense. Okay, and those are my errors. Yeah. Now what I'm going to do is I'm going to say $category view. Sorry, $error view equals category view. And I'm going to do them again. Look at that.
Oh,
so these are these are very pithy ways. And so instead of, I mean, take a look, blah, 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 versus, hey, object not found. In 32, it's 13.
It gives you the value of what it was doing.
What was going on? I was doing a stop process. What was the exception? Process command exception.
You know, I like that a lot, and I haven't seen that before.
Yeah, no, here's the trick. It's always been there, my friend.
Really?
Yeah, look here. So here's the text. Here's where it happened. Category info. It's right there.
Oh, I see what you're saying. So that view is just showing the terse category info that's there.
Yeah.
Oh, that is awesome.
Now, here's the thing. That thing there, it's not localized. That's going to be the same everywhere. As is this fully qualified error ID. Did you ever pay attention to that? Do you know what that is?
Oh.
So look here. Let's do this fully qualified. Let's set it back a second and run it again. It's a normal view. Okay, let's do that. Stop process 13. Okay, this text is all going to be localized, one language to the other.
One language
so
to another.
imagine you're sitting there in Poland, and you run this, and you get this error message, and you're like, oh, I wonder what that is. Well, if you take, I guarantee you, if you take this Polish error text and put it into Bing, it's going to say,
something back in Polish,
I don't know.
probably,
Well,
or
no,
I don't know, or
it's going to say, I don't know. But this fully qualified error ID. Now look what it says. Process, no process found for given ID, comma, and then a location. So a specific error, comma, a location. And the goal of this is you take this guy and you cut it, and then you go in here to Bing, the best search engine in the world, and you paste it, and then you find all the information about that specific thing. So it acts like a unique search engine optimization for all the content about an error you're going to have. Again, you're going to have errors. You're going to have errors all the time. And so how do you get help about the errors? Well, the answer is, well, sometimes we have help documentation, but the space of errors is pretty vast. Right. In general, what you're going to find is that somebody else had this problem, and they've got some blog somewhere that describes what was going on, and then this fully qualified error ID helps you find it.
I love that. That really makes it helpful then to find those errors. And you said it's not localized, so
yeah, it's never localized.
It's always going to look just like that. So you put it into Bing, it rocks no matter where you're at.
Right. And so that also means you might find some Polish blogs about this, but they might not help you.
Might help now. Yeah, I know. Since I can't read it, so.
Well, no, but then you can send it to a translator.
I can send it to a translator. Do we do that in Bing? Do we translate?
Sure.
Oh,
somewhere.
Awesome. Somewhere. Okay.
I don't, but someone does.
Okay, folks, so take a look. We're going to do a little error handling here using this error action and error variable. And I'm going to show you a simple way to do this. And I want you to see the script that I have here. This is the start, number 2, and it's our comp info one. I'm going to minimize the parts that we've already looked at. The switch, error log to make an error log. And I want you to notice that I've already got a log file set up at c::errorlog.txt. And so let me just go ahead and minimize him. My process section, take a look at what I'm doing here. I'm going to take a bunch of computers and I'm going to grab some information. I want some inventory information. So I've got like 3 WMI commands here, and I'm going to create an object. This is fine and dandy, but you know what's a real huge waste of time is if I'm hitting a computer that's in that collection and it's not online. Well, it's going to be banging all of these commands at it, trying it over and over again. It's going to be slow. It's going to be trying to retry. And then when it fails on the first WMI command, what's it going to do? It's going to go to the next command, and it's going to fail on that one. I know it's going to fail, but it's going to sit there and it's going to retry and it's going to retry. And then it's going to fail on the third one, but it's going to sit there and retry it and retry it. What I'd really like is if you get an error, just let's not do this again. Let's not keep going through all of these. So take a look. I've got something called a try-catch block. Now, this is one of the ways that you can try and trap errors and then decide to do something. So look at the simple format here for it. I've got $computer equals not online. We know that doesn't work. So I've got this try catch, and technically it's try catch finally, right?
Yeah.
And a lot of times finally always executes. It's just
Always.
Yeah, a lot of times in a lot of stuff that we're doing in PowerShell, you don't always see the finally in here because we just don't need it.
Yeah.
So if you take a look, I've got try.
Just be clear, so finally is like when you want to do some cleanup, you're doing something, you've allocated some resources, and whether you succeed or fail, you want to clean up. So that's what finally's for.
And so if you're a developer, you probably know the try catch finally really well. You can have multiple catches that catch at different levels. We're not going there, but this is in PowerShell. It's a very powerful implementation.
Actually, you know, it's worth making a point. Sorry, this is completely off topic, But, so here we've been teaching you the scripting, and it just kind of popped in my head, this try catch finally. There's this little secret thing going on. You've been learning C#. You know, by and large, everything that you've learned here, by and large, if you go pick up a C# book, you're like, oh, look, these guys stole all this stuff from PowerShell, you know?
Yes, they did.
Yes,
Yes,
they did.
they did.
No, in fact, you'll find it very, very similar. We chose to be very much matched. And if you know C, same thing. It's going to, you know, C stole from C++, which stole from C, and we stole from them all. And there are variations. Again, I mentioned to you how Bruce and Jim Truer and I struggled with this. Hey, you know, if you just took any of those languages and tried to make a shell out of it, and people have, and they're really crappy shells. It turns out that that syntax just doesn't work for an interactive shell. You need something different. And so we struggled with that, and we came up with what we think is a good interactive shell, but also plays homage to these line of programming languages. And so if you've learned PowerShell and you decide, hey, I'd like to go on and do something else, you'll find it a pretty smooth transition. It is different, but it's very comfortable.
And I want to point that out that a lot of research over many, many years went into you know, admins doing administrative stuff, very verbose languages versus very terse languages, and this really works well. C-based style, this kind of thing works so well for admins. And I just want to reiterate what Jeffrey is saying. If you decide to start moving towards, well, I want to do some more development and I need Visual Studio, the language that you're going then for is C#. You will be amazed at how much you already know because PowerShell is written very similar to using that. And try catch is a great example because it's the same kind of try catch that they would be using in C#, works the same way. So take a look at my try here. What you do is you put your code that you want to try to execute that you think might generate an error, you put that in the try block. And notice what I've got here. I've got Win32 operating system. This $ computer might fail. So I put in an error action. I want you to stop and then put the error into a variable called current error. So I'm going to try that. Now here's the important part to this. You need to stop. That's what gets caught so that we can go to the catch block. If you said continue, well, it's going to continue. It's not going to go to the catch block. The idea here is try this, and if it blows up, stop and let me catch it and put up a nicer error in this case. Look at my catch. I'm going to do write warning. I'm going to put up a slightly nicer error message or a different error message. I could also do some remediation code in here. Maybe I could, you know, try to test the connection to the computer and see if it's really online or not. So let me just run this for you so you can see what's going to happen. I'll clear the screen down here. Vroom. Now, of course, we're waiting for it to fail because not online. But look, warning, you done made a boo-boo with the computer, not online. Yes, cool. Is that kind of cool? It's really cool. So it created a situation, stopped, and now I get to do my own thing. So the point of the try catch block is try what you think might cause a problem, and then error action stop, and then you can deal with it. The other cool thing about this is I haven't lost the error, and even the cool stuff that Jeffrey was showing us, $ current error, there's the error message. And because RPC server is not available, so I can now then put that into a file, however I wanted to do it. In fact, that's what we have right here under the better try catch. I notice I've got help here. This is our function comp info. I'm going to minimize the stuff that we don't need. Take a look. I've got my try block, and I'm trying to make an object for each computer. So I've got all of my codes in here, and whoops, went a bridge too far. All of my code's in here because I'm trying to make this object, and I know the computer might fail. Well, I know that the first time it might fail. I certainly don't need to do the rest of this code. So I'm going to go over here and go error action stop. I'll put the error into a variable, but we'll look at my catch block. Now I've decided that in my catch block down here, I've decided to, going to give you a warning, but if you turned on the switch, which we started out with this morning, error log.
I wondered where that would.
You wondered? I was going to wrap it up towards the end. I'm an amazing kind of guy. So rabbits and all kinds of stuff. So if error log, so if you turn on that switch parameter, here's what it's going to do. It's going to take the date, put it out to a file. I've got a force so that it can, if the file already exists, it'll just overwrite it. It'll take the computer name and put it out to that file, and then the current error. Now, the stuff that Jeffrey was showing us would also be really useful, especially that target instance kind of thing would be useful here. But let me show you how this is going to look. So, let me run this, clear the screen. Whoa, stop doing that. There we go. Down here, clear the screen, get comp info, computer name, not online. We'll do DC so you see that one works, and then we'll do not online. Now, if I don't put in the error log switch, there won't be an error log, so I want an error log. So I'm going to put in the switch parameter for error log, and let's see what happens. Well, there's DC. That's awesome. That's great. I love it. It's a whoop, 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 whoop. Oh, you done made a boo-boo with a computer that's called not online. Really? I wonder what, I turned on an error log, so there should be an error log out here. So let's see what the error log has. DIR, do I have? I'll look errorlog.txt so I can grab hold of that error log. And now I've got the errors in there. And if I was making multiple mistakes, since it's getting appended, it would be added in and added in. So this is a simple way to do error handling, but it gets you started down the road of being able to trap errors when they occur and then do something about the error and record it into a log file. So while it's simple, this is actually a great place to start with your error handling and working with it.
Yeah, that kind of log file is kind of whack, but
yeah, kind of whack, but yeah.
Does write event log?
Oh, yeah, but see, that's the other cool thing, right? So you guys know that you've seen us do like get event log. Instead of writing to your own log file, why not write to the real one?
Yeah, show them that.
So you
know, we should tell. I think we have a little bit of time.
Yeah,
we should show them that, and then tell them about the conversation we had last night.
Which one? Well, I was drinking, so what am I supposed to remember? Okay, so you remember that, and so guys, you've got this commandlet, right?
Yeah, show this. This is good.
Write. I'm not going to be able to show it because write event log, log name, and you get to tell us where you want to write it. So let's say you wanted to.
Application.
Application is a great place for this to go, and you know I'm gonna. I have to specify a source, right? And
yes, and it is Jason saves you money.
Jason saves you. It sounds like an insurance commercial at this point. Money. What else do we need?
Nope. No. Entry type, information.
Is information.
Yeah.
Which you would put in like a script, you'd probably do entry type of like error.
Error, yeah. But this one's different. Where this tees up in the, and then say minus message.
Message.
And then say quote, script, foo ran. Okay.
So you could put this into your script and of course fill in with variables for the message and stuff like that. And so I'm going to run this. Oh, event ID. We forgot event ID.
7.
7. Sounds good to me. It didn't like the source name.
Oh yeah, you got to register a source. Anyway,
you have to register a source.
It's pretty straightforward to do, but there's an extra step here. The point we had this conversation last night, and Jason was telling me how when he and Don train, they do awesome training, and they point out that hey, as you're learning PowerShell, you're really back to this point of like you should maximize. You do your job, and you do your job in a way that maximizes your integrated lifetime earnings. Now, in Rome. Ancient Rome, they had this notion that in order for justice to be done, it was not good enough for justice to be done. Justice must be seen to be done, Okay, so the public awareness that justice was happening was just as crucial as justice actually happening. So too, saving time and saving money is important. Being seen to save time and money is just as important.
Exactly.
So they were talking about how, hey, every time you write a script, you should document the fact that, hey, this used to take this long, and now with the script, it takes this long. And so we were brainstorming about that, and then he said, oh, yes, and at the end of the year, you just go up to your boss and you say, hey, by the way, ka-chunk, here's what I've done, and give me the money. No, I just, here's my value. And we thought, well, geez, well, how do you actually translate that from like, well, I ran this script and it generated this much, saved this much time to what'd that save over the course of a year? And so we thought, hey, this would be simple. If you just wrote your script and every time you ran your script, the first thing you did was you first created the source and Jason saves you money, and you logged the fact that it ran. Then what you could do is say, have a script that says, okay, I'm now going to go across all these machines. I'm going to look in the application event log for that event ID, the Jason saves you money, the source, and the event ID, and then grab that all up, see which script ran, have a table that said, oh, this script saved this much time, and then actually do a calculation and maybe even do a chart. And you do that on a weekly, a monthly, a yearly basis to actually be super crisp about how much time scripting and automation was going to save you. And so anyway, the point is, it's actually pretty trivial to do.
And well, the thing is, and I have to talk to Don about this because this is actually a really cool. You're right. If I was writing this to the event log, that this script or this commandlet got executed, that you've built, what you're doing is you're showing, and you have a way to prove by using get event log, by looking at that ID, you've got a way to show how your tool is being used that you've created. This is good for informational purposes, but it's also good for you to say, hey, look, I reduced the cost of human man hours or human hours down from, I've saved you an entire person. It sounds a little vindictive, but it's time to eat your peers. If they're not automating stuff, if they're not automating and you're probably starting to automate them out. You guys have seen the shirt, and I think it goes something towards the fact of I can replace you with a script. Well, yeah, and that's kind of what's happening. This is a great way, writing it to the event log is a great way to keep track of where it's been run, when it's been run, how often it was used. I think that's a great measurement stick. And that will definitely become part of the conversation now. Yeah. That was brilliant last night. You came up with that. That was awesome. Well, guys, we've done some basic error handling for you, and you've got the examples. And I want to show you where we're at in the slides, because we're going to move on a little bit here and take a look at dangerous commandlets. So error action, catching errors with try catch.
Carlos dangerous.
Carlos dangerous.
Commandlets.
A better example. I showed you a better example.
Commandlets to automatically tweet to all your followers.
Oh yeah, don't. Commandlets
take
to automatically
pictures and tweet. No.
Oh God, that's terrible. So here's.